It has become apparent that many people, atheists included, don't really know what the evidence for the Big Bang is, or how strong it is. Without the actual information, they have no reason to feel as sure, or as moved, as those who claim the theory as tantamount to fact. Why are scientists so sure about an event they say occurred approximately 13.8 billion years ago? How can they talk with such confidence, or indeed any confidence at all, about such a thing? It must be remembered that all the Big Bang theory says is that the universe began in a hot, dense state a long time ago. How hot and how long ago are matters of measurement and calculation. The theory itself does not say the universe came from nothing, although, because they don't understand, or because they don't want you to understand, in the comments section you'll find those that insist that it does. To understand the evidence, you first need a very quick background on spectroscopy. In 1814, Joseph von Fraunhofer noticed dark lines in the spectrum of sunlight when viewed through a microscope. In 1859, Gustav Kirchhoff discovered that the bands were caused by the absorption of light by atoms within the sun at very specific frequencies. The patterns and lines can be duplicated in a laboratory, and this is how we know which element causes which line. Through spectroscopy, we can measure the composition and temperature of galaxies on the far side of the universe. And there's much more to it. The absorption lines move. Sometimes they are found shifted towards the blue, sometimes towards the red end of the spectrum. This is due to the light waves being either compressed or stretched as the source of the light either approaches us or, in the case of redshifting, recedes from us. The same thing can happen if the space through which the light has travelled is stretching or expanding. The first true inkling of the Big Bang came from Einstein, though he didn't know it at the time. When he wrote General Relativity in 1915, he and everybody else believed the universe was stationary and eternal, and had always existed as it appeared through the telescopes of his day. But Einstein's equations disagreed. They demanded that a stationary universe would immediately begin to collapse on itself due to gravity. So Einstein cheated, making what he called later the greatest mistake of his life, by adding to the equation something he called the cosmological constant, a non-existing force just strong enough to stop the universe collapsing. He believed the force had to be real because he believed in an unchanging universe. But a few years later, some other scientists, Alexander Friedmann in 1922 and George Lemaitre in 1927, realized that the cosmological constant was a clumsy bolt-on and removed it from Einstein's equations, and instantly saw a universe that should either be collapsing under its own gravity or expanding. It definitely could not be stationary and static. In 1929, the first direct evidence for the Big Bang was found when Edwin Hubble observed redshifting in the light spectra from galaxies, as if they were all moving away from us. The degree of the shift was greater in galaxies that were further away. Galaxies twice as far away were receding at twice the velocity. This increased rate of recession for the more distant galaxies is exactly what we should expect to see if the space between all galaxies is expanding. With the galaxies moving apart, it was an unavoidable conclusion that they were once closer together. There must have been a time when all the galaxies were virtually on top of each other. Not a great deal happened as regards the Big Bang theory until the 1940s, but in those intervening years many seemingly unrelated things were discovered. Quantum theory was born in the 1920s, and from this, in the 1930s, scientists deduced that stars are like natural factories, formed of hydrogen and some helium, the two simplest and by far the most common elements in the universe. At their cores, where the temperature and pressure are greatest, stars convert the simplest atoms of all into, well, everything else. Carbon, oxygen, nitrogen, etc., giving off light and heat in the process. But there was still the question of where all the hydrogen and helium had come from in the first place. Spectroscopy had told us that the great gas clouds from which all stars form consisted of 75% hydrogen and 25% helium, but where these gases came from was still a mystery. Then, in 1948, George Gamow carried out the first detailed calculations using the new understanding of nuclear fusion and asked, if the universe had a beginning, if all the energy in the universe was once crammed into one place, what would happen? He calculated that it would have been too hot for atoms to exist, and that all that could have existed at such temperatures was raw energy. He knew that after the beginning the universe would cool, and energy would become matter, as per Einstein's E equals mc squared. But what matter would it become? He found that such conditions should result in a universe filled with 75% hydrogen and 25% helium. Now, if you think that's a coincidence, if you think those calculations haven't been checked by generations of physicists armed with increasingly powerful computers, with better and better observations and measurements, you are kidding yourself. But Gamow went further. He realized that by no means all the energy could have been converted to matter. He asked what would have happened to the excess energy from the fireball after 10 or so billion years. He calculated that the light from the birth of the universe would have been stretched, its wavelength lengthened, to way below that of visible light into the microwave region. Furthermore, he calculated the temperature to which the 10 billion or so degrees at the beginning must have cooled. He came up with a figure of minus 268 degrees, 5 degrees above absolute zero. He said the microwave radiation from the initial expansion should still be there, waiting to be detected when instruments one day became sensitive enough. If the Big Bang really happened, the background radiation had to be there. In 1965, Arno Penzias and Robert Wilson, while trying to discover the source of some unexplained radio interference that seemed to come from all directions, accidentally stumbled upon the cosmic microwave background radiation, as predicted by Gamow 20 years earlier. They were awarded the Nobel Prize. In 1990, the COBE satellite went up to take a closer look at the microwave radiation to give us an accurate measurement of its temperature and wavelength. The wavelength is exactly what would be expected if the Big Bang was true, and the temperature was found to be minus 270 degrees, only 2 degrees lower than Gamow's prediction, which, when one takes into account the inferior measurements available to Gamow in 1948, reveals he was pretty much spot on. There are a few other things we should see if the Big Bang theory is accurate. We should expect the universe to have changed over time, and it has. The Hubble Space Telescope has been able to see 12 billion years back into the past and take a picture of the most distant and therefore the oldest galaxies ever seen. Spiral galaxies of today have had time to settle down and become highly ordered. The older galaxies seen by the Space Telescope are not fully formed, indicating that the galaxies of today have evolved from disordered states. Also, quasars, galaxies going through a violent youthful stage, were quite common several billion years ago, while there are none nearby today. More proof that the universe has changed over time. Also, when stars of a certain size die, they leave behind a remnant called a white dwarf. Such objects are the exposed cores of stars that cast off most of their atmosphere or mass long ago. They are very hot and cool off at a very slow and fixed rate. We can calculate their age from their temperature. If the Big Bang theory is correct, the oldest white dwarfs in the universe should be around 13.8 billion years old. And they are. This is what it means to say that the evidence is mutually supportive. All the evidence we have fits. All the answers agree to within a few percent. Bearing in mind that we are trying to understand an event that happened so far back in time, one could almost say the pieces fit with precision. To replace the Big Bang theory, you must have a better theory, one that explains in detail the wavelength, temperature and existence of the background radiation, the creation of matter in the ratios and abundances found by spectroscopy, the apparent ages of white dwarfs, the immature shapes of the distant galaxies, not to mention the fact that the universe is expanding. If you want more convincing, you'll need to read a couple of books on the subject, but I can tell you from personal experience, it's quite a moment when it hits you. Life and living feel different when you know, as near as damn it, that it all started with a bang. I urge you to pursue that feeling.